Good morning, everyone. I am Dr. Shivprakash, Head of the Department of Aerospace Engineering of the Faculty of Engineering and Technology, Ramya University of Applied Sciences. I have here with me my colleagues Dr. Jayhar and Mr. V.R. Kiran, who will be my co-panelists today. The MS Ramya University of Applied Sciences is a private university established in the year 2013 through an act of the Karnataka State Legislature. The university is named after the late Dr. M.S. Ramaiah, a well-known entrepreneur, philanthropist, and educationist. The Ramaiah Group is well known for its long and rich legacy in imparting medical and engineering education. The Ramaiah University of Applied Sciences is recognized by the University Grants Commission and the All India Council for Technical Education. Our university offers undergraduate, postgraduate, and also doctoral programs in a variety of disciplines, including engineering, management, sciences, humanities, pharmacy, dental sciences. We have the Faculty of Engineering and Technology, which has the state-of-the-art facilities, well-equipped laboratories, modern classrooms, well-stocked library, and sports facilities. Our university has collaborations with several international universities and institutions, which provide opportunities for the students and also the faculty members to gain exposure through exchange programs, joint research, and other academic activities. The Faculty of Engineering Technology is one of the largest faculties in our university. It offers undergraduate, graduate, and doctoral programs in several areas of engineering and technology. The faculty is committed to providing quality education, research, and innovation in the field of engineering and technology. The FET, we call the Faculty of Engineering and Technology, is designed to promote multidisciplinary application-based research and help students start their career in the industry and in academia. We have well-qualified and experienced staff members who have expertise in different areas of engineering and technology. The faculty members are actively involved in research and have published extensively in reputed national and international journals. The faculty offers programs in several branches of engineering, including aerospace engineering, automotive engineering, computer science and engineering, mechanical engineering, civil engineering, electronics, and electrical engineering. The Department of Aerospace Engineering, in particular, is committed to providing world-class education to our students, and we take great pride in our diverse and vibrant community. Our faculty members are renowned experts in the fields, and the students come from all over the country, bringing with them a wealth of diverse perspectives and experiences. Together, we are united in a pursuit of excellence in research, education, and service to the society. If you are interested in pursuing a degree in aerospace engineering, we offer a range of undergraduate and graduate programs that are designed to prepare the students for careers in industry, academia, or government. Our curriculum covers a broad range of topics, including aerodynamics, propulsion, materials, structures, and control systems. We also have an active research program that focuses on a variety of cutting-edge topics, including hypersonics, unmanned aerial vehicles, space exploration, and advanced materials. Our faculty members collaborate with other departments in our university, other institutions, and also industry partners to tackle some of the most challenging problems facing the aerospace industries today. So with this brief background about our university, about our Faculty of Engineering and Technology, and also about the Department of Aerospace Engineering, we will now call upon our panel members, Dr. Jahir and Kiran, to start the panel discussion.
Yeah, before starting the discussion, we would like to intimate the participants. If you have any queries, you are please free to put it in the chat box so that we try to interact with you based on the queries which you have raised in the chat box. Okay, it was a nice introduction about RUAS and aerospace engineering by Dr. Pragati. And now we'll try to focus on few of the key questions which students might have uh, facing. Those are something like what is the scope of aerospace engineering after graduation?
Thank you, Kiran. See, aerospace engineers are highly skilled professionals who design, develop, and test aircraft, spacecraft, and related technologies. After graduation, aerospace engineers can have a wide variety of career opportunities in both the public and the private sectors. I will discuss some possible career paths for the aerospace engineers here. Design and development. The aerospace engineers can work in research and development to design and develop new aircraft and related systems. Aerospace engineers can also work in testing and evaluation to ensure that the aircraft and spacecraft systems can meet the safety and performance standards. Aerospace engineers can also work in manufacturing plants to oversee the production of aircraft and spacecraft components. They can work in maintenance and repair areas to keep the aircraft and spacecraft systems in optimal working conditions. The aerospace engineers can work in academia as professors or researchers to advance the field of aerospace engineering. The aerospace engineer who graduate from our university can also work for government agencies such as the Indian Space Research Organization, the Hindustan Aeronautics Limited, the National Aerospace Laboratories to develop and implement aerospace programs of national importance. Of course, you will all know that Bangalore is the home to leading private aerospace companies like Airbus, Boeing, Honeywell, General Electric, Safran, Collins, and there are several startups right in Bangalore. Bangalore is one of the leading hubs for aerospace industry in India. Hindustan Aeronautics Limited, the National Aerospace Laboratories, and the Indian Space Research Organization are government organizations. And the General Electric Aviation, Rolls-Royce India, Safran, Collins, Honeywell, I'm just listed a few of the many private players in Bangalore. So there are several other companies and research organizations in the city that are contributing to the growth of aerospace industry in India.
Thank you, sir, for highlighting about various opportunities for our graduating students after completing their aerospace engineering. Now, we would like to know more about, from the student perspective, what are the higher education opportunities for our undergraduate and postgraduate students?
So, pursuing a higher education is one of the options most of the students opt for after undergraduate studies. So, it's quite famous among the undergraduate students who are graduating from UAS. So, the first and the most commonly common option they go for is a Master of Science in or Master's degree in aerospace engineering. So, pursuing a master's degree in aerospace engineering will give the students an opportunity to gain advanced knowledge and specialized skills in one of the core areas of aerospace, for example, aerospace, aerodynamics, propulsion, materials, or even AI, ML applications in aerospace engineering. So this will give them specialized skills in one of those areas. And the other option is pursuing a master's degree in a related area. That could be mechanical engineering, electrical, computer science. This option, if students pursuing a master's degree in a related area, will give them opportunity to broaden their specialized skills. And they'll be specialized in more than one areas. The other option is to go for management, pursuing a MBA after undergraduate degree in aerospace engineering, which is it's getting very famous among the young graduating students because this helps preparing them for leadership roles later in their career. So they can develop skills in strategic planning, finance, and marketing, which are very important skills for anybody who wants to pursue leadership roles. Another option is to pursue a PhD degree in aerospace engineering. This normally students who are planning for a research career or in academics, those students will plan for PhD in aerospace engineering. Apart from these, there are also short-term certification courses available after BTech in aerospace engineering. These are certification courses which are going to help the students to pursue courses which will specialize, for example, in unmanned air vehicles or composite materials or even computational fluid dynamics. So these are time to time, these sort of courses are offered by universities like RUAS or even other organizations, educational organizations. So in summary, there are several options available for students after BTech in aerospace engineering. Students normally choose a path which aligns with their career goals and pursue it.
Thank you, Jay.
Thank you.
Yeah, thank you, Dr. Jaya. Next question is on how the emerging areas like artificial intelligence and machine learning is used in aerospace engineering applications. Can you brief about this?
Yes. Yeah. Artificial intelligence and machine learning are emerging areas of technology. We all know the revolution that was brought in by the chat GPT. So we believe that it will have a significant role in the aerospace industry. I can list some of the areas where AI and ML may play a significant role in the future in the aerospace industry. For example, the artificial intelligence and machine learning algorithms can be used for optimizing the design of aircraft and systems. These algorithms can analyze data from simulations and tests and identify the design parameters that can be used to improve the performance of the aircraft. I think here the AI and ML can play a major role. AI and ML can also be used to predict the health of aircraft components because safety is a key feature in the aerospace industry and for spacecraft and launch vehicles. It can help in identifying potential issues before they can occur. This can help reduce maintenance costs and also minimize downtime. AI/ML can also be used in flight control systems to improve the safety and performance of the aircraft. These algorithms can analyze data from the sensors and adjust flight controls in real time to improve the stability and maneuverability. AI and ML can also be used to develop autonomous systems for aircraft. Developing autonomous systems for automotive vehicles is already a reality. So soon we perceive such a situation can occur for aerospace industry also. These systems can be used for tasks such as autonomous takeoff and landing, collision avoidance, and navigation. AI ML can also be used to improve the air traffic control systems. They can be used to improve weather forecasting in the aviation and also provide accurate and timely information to the pilots and the air traffic controllers. So to summarize, we believe AI and ML has the potential to transform the aerospace industry by improving in the efficiency, safety, and performance. By the way, aerospace industry is already using AI and ML in several applications, and we only expect that these technologies will become increasingly important in the future. As a matter of fact, realizing and recognizing the importance of artificial intelligence and machine learning, we have already introduced mandatory courses for our students of aerospace engineering in their fifth and sixth semesters. And to add on to that, they can opt for courses offered in the Department of Computer Science Engineering to take specialized courses in AI and ML. So therefore, the course that we offer BTech in aerospace engineering is multidisciplinary. So therefore, they don't have to read only from aerospace related subjects. They can opt to take courses from the computer science. Thereby, their knowledge increases and also their employability also increases. Yes.
Thank you, Dr. Shivaprakasham, for giving a brief introduction about emerging aspects such as AI and ML in aerospace application. Now, we would like to continue our discussion on the important topic of aerospace engineering, that is hypersonic research in our aerospace engineering department. Could you please give a brief about it?
Okay, hypersonics is one of the thrust areas for RUAS, where the university has priority in investing and also establishing research in hypersonics. Hypersonics means we are talking about a speed of more than 5 times the speed of sound. So it has its own challenge. And so hypersonics have applications in space exploration, defense, and also in transportation. So some of the key areas we are focusing, the faculty of the aerospace department is focusing on is in hypersonic aerodynamics, hypersonic propulsion, and also materials for hypersonic flight. So here, aerodynamics, because of the speed, high speed, you have aerodynamic seating and also the drag problem. So we are actively involved in researching hypersonic aerodynamics. And we have also actively publishing research from our work in all the some of the international and national conferences in this in the area of fluid mechanics. So in propulsion, which is another challenge. We are still looking for an answer for propulsion for hypersonic, long-range hypersonic flight, which will most likely be in the form of a scramjet. So we are also actively involved in researching that aspect of hypersonic flight. The other most important is materials for hypersonic flight. So we have experts in materials, that too high temperature materials in our department, and we have actively engaged in researching materials for hypersonic flight, especially materials that can withstand the high heat loads in the form of thermal protection system. So even recently there was an international conference in Bangalore organized by the Indian Institute of Science. So our students published 6 research papers in that conference. To summarize, hypersonic research is one of the priority area in our department, and we are faculties are engaging actively in that area, and also several students, both undergraduate and master's level students, are actively involved in that research area.
Yeah. Thank you, Dr. Jayar, for giving a brief overview of hypersonic research in RUAS. Now we would like to know about one more research topic which is active from many years in RUAS, that is about low Reynolds number aerodynamics. Could you brief upon it, sir?
Yes, Gil. The Department of Aerospace Engineering has a very active and a vibrant research group focusing on low Reynolds number aerodynamics. The term low Reynolds number aerodynamics deals with the study of fluid flow at low speeds and is essential for the design and optimization of small scale flight vehicles like micro air vehicles and unmanned aerial vehicles. The research group in our department is involved in several research projects aimed at developing new technologies and improving the existing ones in the field of low Reynolds number aerodynamics. I will list out some of the key research aspects that we are doing in our department. We perform MAV design and optimization. So we are developing new design methodologies and optimization techniques to improve the performance of micro air vehicles. So we are developing new airfoil shapes and wing designs for micro air vehicles to improve the lift and maneuverability of these aircraft. We have a state-of-the-art wind tunnel where we can design our airfoil and wing and perform testing. This research includes measuring the forces and moments and also studying the boundary layer characteristics and analyzing the flow features around micro and small unmanned aerial vehicles. We also conduct flight tests of micro and unmanned aerial vehicles to validate the design and the testing we performed in our wind tunnel. So from this understanding, we can come up with new design concepts and also think of ways of further optimizing the performance. We also collect a lot of flight data that during this flight test and use it back in our design methodology. So to summarize, the low Reynolds number aerodynamics group in our university works closely with other research organizations, both from the public and the private, to make some advancements in the field. So we take in a lot of undergraduate, postgraduate, and PhD level students, and then train them to perform research in this area, in this exciting area. We also publish a lot of our work in both national and international conferences, and we also encourage our students to publish in good quality journals. Thank you.
Thank you, Dr. Shivaprakash, for giving a brief overview of low Reynolds number aerodynamic research in our ROAS. Next question, we will try to go to the another topic of aerospace industry, that is aircraft structure. Could you brief about the aircraft structure in aerospace engineering department? What are the research activity which is done at ROAS aerospace department?
The aircraft structure is another focus area students and faculty at our department are engaged in. So some of the main focus areas under aircraft structure are composite materials, where we are looking for newer advanced composite materials. And also including we are also studying the mechanical properties and failure modes of these new composite materials. And the other one is finite element analysis, which is very commonly used in structural analysis. We are actively involved in developing new finite element models and also studying the effects of different loading conditions on the structures using these models that we are developing. The other one is fatigue and damage tolerance. So fatigue, as you know, the aircraft's structures are they are exposed to cyclic loads, and fatigue and damage due to the fatigue becomes an important issue. So we are also actively involved in studying those using the finite element softwares that we develop. The other one is the aeroelasticity, which is also related to the cyclic loads that the aircraft structures experience. So we are also actively involved in researching aeroelasticity. So in summary, we have faculties engaged in several aspects of aircraft structures, researching and teaching, and students are also involved in learning and researching this area. And students do go to conferences and publish their work and also publish in quality journals.
Yeah, thank you, Dr. Jaya, for briefing about aircraft structure research in ROAS Aerospace Engineering Department. Okay, for next question, sir, could you please tell us about the unique features in Aerospace Engineering Department at ROAS?
Please. See, in our the Department of Aerospace Engineering, we operate a low-speed wind tunnel. So this tunnel is used for teaching, research, and also it serves the industry also. It is a closed-loop wind tunnel with a test section size of 600 mm by 600 mm and 1.2 meters long. This can generate wind speeds of about 40 meters per second, where we can test our micro vehicles or unmanned aerial vehicles at velocities of about 40 meters per second. The tunnel is equipped with instrumentation to measure the lift, the drag, and the moments. Also, we can measure the velocities and pressure fields around the model aircraft that are placed in the wind tunnel section. We also have a pressure scanner, a 6-component force balance, and hot wire anemometers. This tunnel is being used for a wide range of research and teaching activities. So we are using it for studying the flow over an airfoil, over wings, over micro air vehicles, to study the boundary layer behavior, and also for flow control. The tunnel is also used for testing and validating the numerical simulations and computational models that our students develop. See, our students develop computational models, perform numerical simulations. They can now go to the wind tunnel and perform experiments of the computation models they have created in the lab, and then they can compare. So thereby, their understanding of aerodynamics, we believe, will enhance. So we are also using these tunnels to provide hands-on experience of planning a wind tunnel experiment. Secondly, we also have a supersonic wind tunnel in our department, where we can reach very high speeds of up to Mach number 3. So this tunnel is equipped with instrumentation and measurement systems, including sclerin, pressure sensors, temperature sensors, which enable the students to measure and also visualize the aerodynamic features. This tunnel, the supersonic wind tunnel, is being used for a variety of research activities pertaining to high-speed aerodynamics, including shock waves and boundary layer interaction. The facility is used for testing and validating the numerical simulations that the students do in the simulations laboratory. We also have an aeromodeling lab. It's a very special feature of a department where the students who enter the first year of engineering are taken to the lab, the aeromodeling lab, and they are encouraged to build some small micro air vehicles. So we encourage the students to do lots of hands-on, to come to the lab, given a set of design specifications, they discuss with the faculty members and also with their group members and design an aircraft. And then what we actually do, after the design is complete, we do a flight testing. So these students do this in the first semester and also the third semester and in the subsequent years. So we have a large number of existing aircraft models and also the models which the student will create as part of their coursework. I'm also glad to tell you that we are having a Ramaiah satellite project. So this project involves the design, the building, and operating a nanosatellite. So the Department of Aerospace Engineering is an integral part of the development of the satellite. So the students are trained in designing, building, testing, and operating a nanosatellite class. So the students will get exposure to test and learn new technologies and solutions related to space exploration and communication. The Ramya Sat project is being conducted in collaboration with the Indian Space Research Organizations. It also provides a platform for the students to interact with industry professionals and also experts in the field of space technology and also to gain valuable insights into this exciting field. We recently inaugurated the Ramaiah Satellite Ground Control Station, where we have already receiving signals from weather satellites. I should also tell you that we have state-of-the-art computing facilities and modern software to perform simulations. We are also in the process of establishing a high-performance computing center that would enable us to do compute-intensive simulations. We are in the process of establishing this center, and I hope the center will be established soon. Yes, Kiran.
Thank you, Dr. Shivapragasham, for briefing us on the unique features at RUA's Aerospace Engineering Department. Students, if you have any queries, you can try to drop in a chat box so that we'll try to address your queries at the end. Sir, we would like to also inform the students or participants about the innovation and entrepreneurship cell, which is there in RUAS, Ramaya University of Applied Sciences, and under RTBI, we have around 25 startups or an incubating facilities is also available. To name a few, startups such as Viman Drone Labs, Aerosite Technology, Agri Drone, and also we have a collaboration with Pina Industrial Association, PIA, and also Genser Aerospace to our department. And in a curriculum, we also highlight on entrepreneurship development to start or to nurture the young minds to set their mind on that particular entrepreneurship aspects. These are the other important areas which we'll try to focus on the curriculum of our aerospace engineering subject. Sir,
Thank you, Kiran.
anything you would like to add upon this?
If there are any questions in the chat box,
Yeah.
I think we can take it now.
Sir, please tell me about placement in aerospace engineering after undergraduate.
Dr. Jehar, would you want to answer this?
You can take.
See, the students after their undergraduate program, there are several career opportunities. The first what they can think of is the public sector. The public sector is like the Hindustan Aeronautics Limited, the National Aerospace Laboratories, the Indian Space Research Organization, the Defense Research and Development Organization. The placement to these government organizations is usually through a common, what they call as the scientist entrance test. So to write the scientist entrance test, it is important for the students to be gate qualified. So what we do, when the students come to the final year, that is during the 7th semester, we encourage the students to prepare themselves for clearing the gate exams. So at the time of writing the entrance examination, they should have a valid gate score. And then the call for placements in these organizations I just mentioned is through a national advertisement carried out in national dailies. So then with the valid gate score, you apply for these scientist entrance test. So it is a pan-India and a competitive examination. Once you clear the pan-India competitive examination, you are called for an interview by the respective organizations. So you will have to clear the interviews conducted by these organizations, and then you can enter into the government organizations. This is the route normally taken for the government organizations. On the other hand, you can think of a placement opportunity in a private company. For example, as I mentioned earlier in this webinar, Airbus, Boeing, Honeywell, General Electric, Rolls-Royce, Safran, Collins, all major aerospace players are right here in Bangalore. So what these big companies look for is good academic credentials starting from the 10th standard. The standard 10, the PU1 and PU2, and good academic credentials over the 4 years of program. And once again, the recruitment to these major companies are through the advertisements they post either in websites or through the national dailies. That is one option one can think of. Alternatively, students can also explore the opportunity of getting placed in service companies. For example, HCL, Wipro, Infosys, TCS, all of these companies, the service providers, they recruit engineers. In particular, if these companies are interested in doing projects in the aerospace segment, they would certainly need aerospace engineers to carry out those projects. So the service providers come for campus placements and do a lot of recruitment from our university as well. The last option I would also tell you is to try a startup. As Kiran mentioned, we have the Ramya Technology Business Incubator set up right in our campus. So if you have a brilliant idea which you think can be made as a product and then be commercialized, so the RTBI invites such applications and evaluates them and then incubates and nurtures it for a period of up to 5 years with funding from both the Ramya group of institutions and also from the government of Karnataka. Indeed, I'm glad to share with you that 3 of such incubators who are now in the Ramya Technology Business Incubator are our own students who did their final year projects and then thought their project can be converted into a product. So they are currently being incubated. We also provide opportunities for the current students to go and work with these incubators for 2 reasons. One, they'll be inspired to do they'll come up with a product on their own. And secondly, the startups offer a lot of opportunities for you to learn many things. So these are the several career options as I see now for aerospace engineers.
Yes,
Thank you.
thank you for answering that question, and I think has given a brief idea about what will be the placement opportunities after completing the undergraduate.
In the meantime, Kiran,
Yes.
would you want to talk about the internship opportunities our students we are providing to the students?
Yeah, students are encouraged to take internship during their semester break time so that they will have enough time to spend in an industry. Presently, students have taken part in ISRO, HAL, NAL, LNT, HCL, and also M Drone India Private Limited, that is a drone-based company. They are working all on this particular area during their leisure time, and those leisure times, whatever they spend, that can also be converted into credits. We are incorporating that credit system will be transferred to that particular course. Whatever you have done during your leisure time, that will also be considered as a credit. So whatever the things you have learned, that is an advantage which can be claimed under a credit. Yeah, I think that is.
Yes. And also maybe at this point of time, I would like to inform the viewers that from the present academic year, we are implementing the National Education Policy 2020. We call the NEP 2020 into all engineering programs, including the aerospace engineering. The NEP 2020 offers flexibility to the students in choosing their courses. The curriculum is what we call as a choice-based curriculum. The students are free to choose courses apart from their core area of aerospace engineering. For example, if an interested student can choose courses from the Department of Computer Science Engineering. For example, they can choose a course on data analytics or data science and management. They can choose courses from electrical engineering. They can choose courses from management. So this kind of a flexibility, the NEP allows the students to do. We are also focusing a lot on outcome-based education. And the choice-based curriculum framework will be implemented from this academy.
It's good to know that NEP is getting implemented and students will have better opportunities and skill sets to be future citizens. Next question is on, sir, in academic wise, what is the difference between aerospace and aeronautical engineering? This is the most common questions which students will have whenever they try to interact with academicians. Could you answer this?
Well, when you talk about aeronautical engineering, all that flies within the atmosphere can be categorized into the aeronautical engineering. For example, aircraft, micro air vehicles, unmanned air vehicles, helicopters, all these form part of the what you call the aeronautical engineering. However, when you say aerospace engineering, we also encompass things which go beyond the atmosphere. What are the things that go beyond the atmosphere? For example, launch vehicles, missiles, satellites. They go beyond the atmosphere and then they form as a part of the aerospace engineering curriculum. In our university, we offer BTech in aerospace engineering. So that incorporates courses on launch vehicles and missiles, rocket technologies that we study in propulsion 2, satellite technologies as an elective, and orbital mechanics and control. So I hope this will clarify at least a bit about the difference between aeronautical engineering and aerospace engineering.
Yeah, thank you, sir. And next question, which companies come from placements in aerospace engineering?
For the placement, several companies, for example, recently the numbers you mentioned, Larsen & Toubro Technology Services, they came and recruited large number of our aerospace engineering students with paid internship. And also, if they perform well in the internships, there is also a possibility of these students getting absorbed as permanent employees in Larsen & Toubro. We also had recruiters coming from HCL. We also had recruiters coming from Gensur, where our students regularly do their internships and get placed. We also have a large number of private companies that come and do the recruitment for the aerospace students, both at the undergrad and also at the postgrad level.
Yeah, thank you, sir. More question. What is the scope of aerospace industry, keeping in mind the advancement and development of AI? What do you say the robot cannot take our job completely?
Well, in the earlier part of our webinar, we had discussed about the role played by the possible role that could be played by artificial intelligence and machine learning. At this point of time, it is very hard to predict the future. But what I can tell you, the artificial intelligence and machine learning can supplement or complement what the humans can do. It may not be in a position to completely overcome what the humans are doing at the present stage. So I think we all believe that the aerospace industry will still be a vibrant industry and it would still need graduates, humans to do certain jobs.
One more question. After completing the undergraduate in aerospace engineering, it is better to do higher studies in aerospace engineering or to get into the job after undergraduate? What is the better one you will try to point out?
Well, it's something which depends on individuals, right? And from our experience, students opt for both options, based on what their goals are, career goals, and personal ambitions. So having the opportunity to go for higher education is seen favorably by many students because it adds more skills, and you are also getting an opportunity to specialize in a particular area. So many students do take the opportunity to go for higher education, specialize in one of the core areas in aerospace. If not, they go to some other related areas also, like I mentioned before. But there are also other group of students who like to go find a job, and because many of the companies they take them as interns or a beginner or a, it's a beginning role, like you're not the pay scales are not going to be high. So for that reason, some students go for higher education to get specialized skills so that they can go for the jobs which are more specialized and pay is also higher. The other side, students also opt for jobs so they can start working at a very early age and keep building their career.
Thank you. And one more question. What is the cutoff for aerospace engineering at ROAS?
Well, the cutoff, I presume this cutoff the student is asking about the KCET cutoff.
Yeah.
It is difficult to give a precise number for the cutoff because it varies from year to year and also from program to program. For example, some of the toppers or the students who have a very good scores in the KCET, they get admitted into the aerospace engineering programs in the first round of counseling. However, you all know that there will be the second round, third round, and also the supplementary round, where students with a lower ranking also can come and join. So therefore, we attract a wide students with a wide range of KCET scores, and also students from the different parts of the country. Thereby, we provide a vibrant environment in the student amongst the student community.
Thank you, sir. Can I get an admission into aerospace branch using JEE scores?
Yes. Yes, one can get an admission into the BTech in Aerospace Engineering program using the JEE scores. I would request you to call up our admissions office, whose email ID and the telephone number we will share at the end of this webinar.
Is there a scholarship for student who wants to study abroad? Can you explain the process?
The scholarship for the students who want to study abroad, the students should first of all have very good academic credentials for them to apply for higher studies in universities abroad. And they should apply for the scholarships offered by that university. So I hope there are several such opportunities offered by many universities abroad. Jehar, what do you think?
Yeah, I mean, the students who are graduating from RUAS, let's talk about the undergraduate students. Most of them graduate with a lot of research experience, having conducted research and published conferences, in some cases journals also. So they have a very good, they are in a very good position to get scholarship. We have students who have gone to very highly respected, prestigious institutes all around the world, especially in the United States and in Europe, and they have secured scholarship. So the ecosystem is very much in favor of helping the students to get experience, hands-on experience, which is seen favorably by the abroad institutes, and they will definitely like to hire those students. So we're having very good success in this area because of the ecosystem we have in our department and throughout us.
Yeah, one more question. Last question. Sir, what is the salary we can get in India after completing aerospace engineering?
Well, that typically varies depending on where you are placed, whether you are placed with Boeing or Airbus or in a startups. Okay, but however, on an average, it is about 6 to 12 lakhs per annum that students get as a fresher with a fresh degree in aerospace engineering.
Thank you, sir. I hope we have answered all the questions which students have posted in the chat box. For more queries, you can contact phone number 801 000 4444 and you can email us at admissions23@msrus.ac.in. And for more information, you can please log into our university website www.msrus.ac.in.
Well, I thank you all for joining this webinar, and I would invite you to explore our website and also come and visit us in both our campuses if you need any further information. We'll be glad to provide. I hope this webinar was instructive to you, and I look forward to meeting you all. Thank you.
Thank you and all the best for the participants.
And I also thank my panel members for participating in this interactive session. Thank you.
Thank you.